All right, so we're about to move into a unit on volume and density, which are two big things that are on your EOC, and just kind of two big topics that we need to review before you leave geometry. So before we do that, one thing that you really need to know, we've talked about perimeter, and we've talked a little bit about area just here and there, but we really need to make sure that we know basic area. So most of this is a review from, honestly, from elementary and middle school, but you haven't done it in a long time. So you've probably forgotten some of these things, or if you know them, I'm just reminding you of a few specific little parts about each one. So the first category we're going to talk about is parallelograms. So I want you to remember that the parallelogram family has a few different things in it, right? It has rectangles, it has rhombuses, and squares, and parallelograms themselves. So this formula is going to work for all parallelograms. So I'm going to actually draw a parallelogram, and I want you know how to find the area of a rectangle, right? You all in elementary school or middle school somewhere, they teach you it's length times width. I want you all to change that and remember the area of a parallelogram is base times height. And I know you might say, well, that's like the same thing, but in high school geometry, we see base and height more regularly, not length and width. That's kind of elementary terminology. So the two things that you need to know is that base and height, these two measurements, must be perpendicular. Okay, so when I say perpendicular, I'm talking about like this could be the base, right? But the height is not the slanted side. It is not this slanted side over here because that's not perpendicular. The height would be an additional part that you draw in here that is perpendicular. So that right there would be the height. All right, so triangles, and then I'm going to do some examples of all of these. So triangles, it doesn't matter what type of triangle it is. A triangle comes from, I feel like in elementary school you learn that you might have a rectangle, which is base times height, and you can make a triangle by cutting that in half, right? Now you've got two different shapes where you've got a triangle. So the formula for a triangle, didn't want to erase that. The formula for a triangle for area is area equals 1/2 base times height. Or some of you might prefer to do base times height divided by 2. And I don't care which one you do. Again, base and height need to be perpendicular. So even if you have a triangle, let's see if I can move my picture here. All right, if we've got a triangle that, let's see, looks like this, base, and that's not kind of how I wanted to draw that. Let's do that again. All right, if you make your base down here at the bottom, go back with my colors, this is base. Then height is this perpendicular that you have to drop down. It's not one of the sides, so they have to be perpendicular. All right, the last one that we want to talk about today is circles. And so we've done circles before, but we'll just touch on them again. So circles use radius for area, and so area is going to be pi r squared. Remember that this squared is only on the r. So if you need to write that down, this exponent is only on the r. Exact area will keep the pi in it. And then remember, you need radius, so if they give you diameter, you might have to cut that in half before you can use that in your equation. All right, so the last little note, area is a 2D measure of the space inside of a figure, and it is measured in square units. So your answers will be things like inches squared, meters squared, feet squared, etc. Okay, I just want to show you that not all area is super simple, and of course there are some formulas for other things, but just in case we encounter some more complex problems, there are things called composite shapes, and those are shapes that are made of other shapes. So what I've given you are the three kind of that we can go back to. So this first one would be a hexagon, and I know this is not drawn well, but anything any type of polygon can be done like this. You may say, well, what could I do there? There's a few different ways to do this, but the most common way is to split this shape up into triangles. So for instance, this is going to give you one triangle, right? And since the hexagon, it has 6 sides. So what you could do is find a triangle and then multiply your answer by 6. And so then remember, area of a triangle would be base times height. So you would do base and height and then multiply that by 6. All right, this second one over here, notice that this, if you split this apart, you could split this into half of a circle. And so like this top half is a circle and then a triangle at the bottom. So the area of this one would be, you would do half of a circle plus, then you would have to add in the area of the triangle. And so that would give you the entire thing. So when you do that, remember that you've got 2 different shapes going on, right? So you would do pi r squared for the top. And then you would have to do half of that because you only want half of the circle. And then you would do the triangle at the bottom, base times height. And then you also get things like trapezoids. They do have a special formula, but in general, the easiest way to maybe find a trapezoid is to cut it and get yourself one rectangle. Let me move this. So the area here, goodness y'all, the area here would be one rectangle plus 2 triangles. And remember, these triangles might be different. But in this case, you would be making right angles right here. So it would be base times whatever these heights are right there. All right, so just remember that there are some other things you might encounter.